inside the apparatus. And I want to think about the electron inside the apparatus while all walls are out. So it's this experiment. Consider the single electron. We know with total confidence, with complete reliability, that every electron will exit this color box out the white aperture. We've done this experiment. We know it will come out white. Yes? Here's my question. Which route did it take? You determine they are. And if our arguments are correct, and that's on me, then they're doing something, these electrons are doing something we've just never thought of before, something we've never dreamt of before, something for which we don't really have good words in the English language. Every single object that goes through this apparatus does not take the hard path, it does not take the soft path, it doesn't take both, and it does not take neither. And that pretty much exhausts the set of logical possibilities. So what are our electrons doing when they're inside the apparatus? How do you describe an electron inside the apparatus? You can't say it's on one path, you can't say it's on the other, it's not on both, and it's not on either. What is it doing halfway through this experiment? The word superposition would go something like this. An initially white electron inside this apparatus, with the walls out, is neither hard, nor soft, nor both, nor neither. It is, in fact, in a superposition of being hard and of being soft. And we call it superposition. Okay? Now, at the moment, superposition is code for, I have no idea what's going on. Okay? Very different regimes. When we work with atoms, when we work with molecules, when we work in the regime of very low energies and very small objects, your intuition is just not a reasonable guide. It's not that the electrons, and I cannot emphasize this strongly enough, it is not that the electrons are weird. The electrons do what electrons do. This is what they do, and it violates your intuition, but it's true. The thing that's surprising is that lots of electrons behave like this. Lots of electrons behave like cheese and chalk. And that's the goal of 804, to step beyond your daily experience and your familiar intuition and to develop an intuition for this idea of superposition. And we'll start in the next lecture.
Interesting things. Things that bowling balls would never do. They can split. They can combine. If I sent a wave of water through the double slits, it would split in two, and then the two sets of waves would intersect. Their peaks and valleys would combine, getting bigger in some places, smaller in others, and sometimes they'd cancel each other out. With the height of the water corresponding to brightness on the screen, the peaks and valleys would create a series of stripes and what's known as an interference pattern. So, how could electrons,
And the answer
which are
is because
particles,
electron behaves
form that
like particle
pattern?
as well as
How could a
waves
single
and is
electron
always in superposition state. That's why.